Okay guys, so we're going to start reviewing for test number 2 of the third quarter. And this mainly deals with the trig stuff that we've been working on in class. So the first question is solve for the missing variable using right triangle trig. If you ever see right triangle trig, you should know that that means SOHCAHTOA. Okay, again, we're not really going to touch more on that in class. So SOHCAHTOA is when the sine is equal to the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Okay, so for this question, for number 1, I have that this angle measurement is 47 degrees. This is my hypotenuse, and this is adjacent. This is right next to it. So this is going to be the cosine of 47 degrees is equal to the adjacent divided by the hypotenuse. Okay, so now I cross multiply and I get x equals 24 times the cosine of 47 degrees. That you can type right into your calculator. Make sure, because this is the cosine of 47 degrees, that you are in degree mode. So this really should tell you where to round to, but if we round to the nearest hundredth, you get x equals 16.37 for number 1. Okay, so the second question deals with points on the unit circle in comparison to the sine, cosine, and tangent. So if you remember our 3 identities, we have that the sine of theta is equal to y, the cosine, so let's write this down, sine of theta equals y, the cosine of theta equals x, and the tangent of theta equals y over x, which is the sine over the cosine. Okay, so for number 1, we have sine, this again, these points are on the unit circle, that's why we can do this. We have the sine of theta equals the y value. The y value in this case is 3 over 5. The cosine of theta is equal to the x value. So the cosine of theta is negative 4 over 5. And then the tangent of theta, so underneath, if we set that up as a complex fraction, we have the sine of theta, which is 3 over 5, divided by the cosine of theta, which is negative 4 over 5. So then when I simplify this, I do keep, change, flip. These end up canceling, and I get the tangent of theta is equal to negative 3 over 4. Okay. Now for the second part here, so now we have a radical, so we could run into some trouble here. So to start, we have sine of theta equals whatever my y value is, because again, we're still on the unit circle. It tells us in the directions that we're on the unit circle. Sine of theta equals 2 times the square root of 2 over 3. The cosine of theta is whatever the x value is negative 1 over 3. And now my tangent of theta, I set up that complex fraction. Again, I have 2 square root of 2 over 3, all divided by negative 1 over 3. So this is really 2 square root of 2 over 3 times 3 over negative 1. These cancel, and I end up with negative 2 square root of 2 for the tangent of theta. Okay. For questions 4 and 5, it tells you that point A is on the unit circle, and it gives you what your angle measurement is. So here you are going to do your x value is whatever the cosine of theta is, and your y value is whatever the sine of theta is. So in your calculator, this says to round to the nearest hundredth. We have the cosine of 245, comma, the sine of 245. Again, you are in degrees, so make sure you are in degree mode in your calculator. We haven't talked about radians yet for this test, so make sure that you're in degree mode the entire time. So for number 4, in your calculator, the cosine of 245 degrees, round to the nearest hundred, is negative 0.42, comma, the sine is negative 0.91. Okay, I know that I have to be in, these both have to be negative because I have negative x values, negative y values to get to point A. Okay, And then for number 5, I'm sorry. For number 5, this would be same thing. We're on the unit circle, so x is the cosine of theta, y is the sine of theta. So cosine of 140 degrees, comma, the sine of 140 degrees, the cosine of 140. You can type right into your calculator, round to the nearest hundred still is negative 0.77. And then the sine is 0.64. Okay, if you get a question like this and you end up with one of those special decimals that we talked about, and I ask you for exact, here I told you to round to the nearest hundredth, but if I ask you for exact value, you need to know those special angles that we talked about in class that we've been drilling on all week. Okay, so let's talking about these. So these are some of my special angles. So these you really have to just kind of commit to memory, know how to do them. All right, so for example, I have, let's just talk about a general case. We have sine, cosine, tangent, 30, 45, and 60. We have 1, 2, 3, 3, 2, 1. So what I mean by that is 1 over 2, 2 over 2, 3 over 2. And we're always talking about square roots. Cosine now goes backwards. So this is the square root of 3 over 2, square root of 2 over 2. And then the cosine of 60 is 1 over 2. And then finally for tangent, you can do sine over cosine, or if you commit it to memory, it's a little bit easier. So 30 degrees gets the extra 3 for the tangent. The tangent of 45 is sine over cosine. If you divide a number by the same thing, you're going to get 1. And then the tangent of 30 is just going to be the square root of 3. Okay, so then for your quadrantal angle, so angles that are on the axes here, remember your unit circle. So this point here is 1, 0. This is 0, 1. 1. This is negative 1, 0, and then this is 0, negative 1. Okay. So from here, I think you guys can pretty much figure that out. You can also, if you don't remember these, you can type them right into your calculator. But if I ask you, you see how this says exact value in your directions? You need to write, if it's the square root of 3 over 2, you can't write that as 0.8660. Okay, if you type it into your calculator, you need to be able to convert it back into its exact value. So if you don't want to, if this is hard for you to remember, then you need to remember the decimals for the exact value. Okay, moving down for 9 and 10. Rewrite the following as a function of a positive acute angle. Positive acute angle deals with the reference angles. Okay, so for number 9, the tangent of 300 degrees. So first, 300 degrees, that is in my 4th quadrant. And in my 4th quadrant, and all students take calc, only the cosine is positive, so this is going to be negative tangent. And then you have 300 degrees. So the reference angle for 300 degrees, how far away am I from the x-axis? I am 60 degrees away. Okay, so you can actually figure this out. You can find the exact value for this because you know that the tangent of 60 degrees is the square root of 3 from right up here. So this is what I'm asking. This would be your answer. However, you should know that this is also the negative square root of 3. Okay, but again, the circled part is your answer. So then for number 10, same thing, the sine of 225 degrees. So first, 225 degrees, that is in my 3rd quadrant, and only tangent is positive, so this is going to be negative sine, and then my reference angle here is 45 degrees. Okay, so this, again, this part here would be your answer. But you need to know sine of 45 and then negative. That's going to be negative square root of 2 over 2. Okay? And then this last part down here for 11 and 12. For number 11, we have to find, because if you remember, if you're looking for the degree of your question, you need to do the inverse function. So in your calculator, you would press second, then cosine of negative 0.3420. So it would look like this. And then negative 0.3420. Okay, so when you actually do that in your calculator, you end up getting 110, right? So 110 degrees, that's over here. So I need my reference angle. My reference angle from 180 to 110 is 70 degrees. So I need to keep that in mind because I have to be in the third quadrant. So third quadrant is over here, and then I'm going to be 70 away from the x-axis. So I need to go 70 this way. So if this is 180, when I add 70, then my final answer here, let me get rid of this because this might be confusing. My final answer here is going to be, I just did 180 plus 70, and I got 250 degrees. For number 12, I have the tangent. Again, I have to do the inverse because I'm looking for a degree measure of negative 0.3640. So when I do the inverse function in my calculator, I end up getting negative 20. So negative 20 is right here. I am going to be 20 degrees away from the x-axis, so my reference angle is 20 degrees, and I have to be in quadrant 2. So if I take that to be in quadrant 2, I need to be 20 degrees away from here, so I would do 180 minus 20, and I get 160 degrees. Okay, so moving on to 13 and 14. So these are going to start getting a little bit more involved once we hit, when it asks you for the degree, kind of like what we just did on the last page. So for 13 and 14, the beginning part should be pretty straightforward. For number 13, these points are on the unit circle, so I have those three identities. Sine of theta equals y, cosine of theta equals x, and then the tangent of theta equals sine over cosine. Okay, so for point A, for question 13, for point A, sine of theta is my y value, so sine of theta is the square root of 3 over 2. So right away, bells should be going off. Square root of 3 over 2, that's going to be one of my special angles. Cosine of theta is negative 1/2. Okay, and then when I do the tangent of theta, the square root of 3 over 2 divided by negative 1 over 2, if you actually go through and do that, you end up getting negative square root of 3. Okay, so you should be able to recognize that my reference angle in this case is 60 degrees. Okay, but because only sine is positive, I'm going to be in the second quadrant. If my reference angle is 60 degrees in my second quadrant, then I am going to be at 120 for theta. So theta equals 120 for that one. So then 14. So 14 is a little bit more involved because it's not going to be a special angle. So 14, we have that the sine of theta is equal to negative 3 over 5. The cosine of theta is equal to negative 4 over 5. That's my x value. The tangent of theta is going to be equal to negative 3 over 5 times 5 over negative 4. So these cancel. Negative 3 divided by negative 4 is just positive 3 over 4. Okay, so now I have to think. So I have to find theta now, round to the nearest degree. So only tangent is positive, so I have to be in quadrant 3. If you plug in any one of these functions, you're going to end up getting that your reference angle is going to be 37 degrees. Okay, we're in quadrant number 3. So I have to be 37 degrees away from the x-axis. So here I would do 180 plus 37. So my final answer, I get theta is equal to 217 degrees. Okay? Alright, so now we're going to start in with some word problems because we didn't really touch much upon this for the last test. I think it was just half-life that we did on there. So now we have all of those equations that you need to know. Okay? So for number 15, you are observing a radioactive isotope to find the half-life. Okay, so you need to know half-life formula. So half-life formula is A equals P times 1 over 2 raised to the time divided by H. You may also see, instead of P, A sub 0. It just means it's the initial value. Okay, so here, we're starting at 2 p.m., we're ending at 7 p.m. So the time, I'm looking for H, right? I'm looking for H. The time, it has only been 5 hours. Okay, so right now, time, it has been 5 hours. I'm looking for H. The 1/2 stays the same. And then here, you're starting at 2.5. So 2.5 is going to come here. And then 1.7 is your final amount. Remember, half-life, you're getting smaller. So your initial amount should be larger than however much you end up with. So the first thing I have to do is divide by 2.5. So 1.7 divided by 2.5 on my calculator gives me 0.68. Remember, if you have a long decimal, don't get rid of it. Do not round until the very end in your calculator. So don't get rid of all of those decimals that are in there. So now I have this. I'm going to rewrite, you don't have to, but I'm going to rewrite the half as 0.5 raised to the 5 over H. So I have to bring that H down to the front. So I am going to use logs for that, because with a log, this brings this out to the front. So now I have the log, I'm going to come up here, of 0.68 is equal to 5 over H times the log of 0.5. So now I divide by the log of 0.5, divide by the log of 0.5. So over here I get this nasty decimal that looks like 0.55639. Don't clear that though in your calculator, equals 5 divided by H. So this is a big mistake that people were making on their last test. So what everybody wants to do is they just want to multiply both sides by 5 because that's what we're used to. However, think about what you're actually doing. Okay, this is really over 1. If we cross multiply, we have 5 equals 0.55039 times H. So now I have to divide by this to get to H by itself. So that's why I told you not to clear in your calculator. If you want to use that store button I showed you, you can do that as well. So your final answer, you end up getting, and it says round to the nearest thousandth, you end up getting that the half-life is equal to 8.986, and we were talking about hours. So now for 16. Interest compounded quarterly, so that's not compounded continuously, so you are not using PERT. This one is A equals P times 1 plus the rate over how many times it's being compounded. So how much money will be in the account in 5 years? That means that you are actually looking for A. So A is what you're looking for. So that's going to stay the same. The initial amount, P, is going to be 4,000. This is going to be 1 plus my rate. Remember, I have to move my decimal over. So 6% is actually 0.06 divided by, if something is happening quarterly, that means that it's happening 4 times per year. So over 4, and this is 4 up here also, times, it's going to be 5 years specifically for this question. So this whole thing here, you can type right into your calculator. When you type that right into your calculator, you should get 5,387, and we always round money to 2 decimal places. So $5,387.42. Okay, so moving on. So we have another one up here that deals with money. So it's probably going to be interest. So let's just see. So this says interest compounded semi-annually. So this, again, this is going to be the same formula that we just used. So this is going to be let me see. A equals P times 1 plus the rate over N raised to the N times T. So my question is, how long will it take to get for the account to obtain $12,400? So I am looking, in this case, I am looking for T. So that's the only thing that I'm not plugging something into. So I want my final amount. My final amount should be 12,400 equals 8,500 was how much I started off with. 1 plus my rate is 0.042 divided by N semi-annually. So semi-annually is happening twice per year. And then 2T. Okay. So because I have that variable up there, I am going to need logs for this. So first I divide both sides by 8,500. So it's going to be 1.488823 equals. If you want to clean this in whatever's in your parentheses up, you can. So if you do that, you get 1.021 raised to the 2t. So I have to bring my exponent down, so I need logs. So log of 1.488823 equals 2t times the log of 1.021 divide by the log of 1.021. 1.021. So this gives me a nasty decimal. 18.17055. We'll round it there, equals 2t. Then divide by 2 to get t by itself. But because this says nearest whole year, we get t equals 9 years. Next question. This is talking about annual interest compounded continuously. So compounded continuously, that is going to be your PERT equation. A equals PERT. Okay, so there's two parts to this question. The first part, how much money will you owe? So how much money will you owe talks about finding A. Okay, so this is a rather easy question. So how much money will you owe them after 1 year? So I'm looking for A. My initial amount is $3,000. E raised to the rate is 12%. 12% as a decimal is 0.12, and then the time it's been times 1 year. So this whole thing you can type right into your calculator because you don't have any variables in your exponents. So you end up getting A equals 3,382.49. Okay, so that's for part 1. For part 2, how long will it take for you to owe your parents $4,500, rounded to the nearest tenth of a year? So keep in mind you're rounding there. So this is still the same formula. This is going to change. P is always going to be 3,000. E is always E, and then your rate in this particular case is always 12%. Okay, so this time though you're looking for T. So this time you're going to need logs. So you're going to plug in 4,500 equals 3,000 e to the 0.12 t. Divide by 3,000, you get 1.5 equals e to the 0.12 t. So because you have an e here, it might be easier for you to take the natural log. So why don't we go ahead and do that instead? So it's going to be the natural log of 1.5 equals 0.12 t times the natural log of e. Natural log of e is just 1, so that cancels out. So all I have to do is divide by 0.12, divide by 0.12. So in your calculator, you would do the ln of 1.5, close your parenthesis, divided by 0.12, and you should get rounded to the nearest tenth that the time is equal to 3.4 years. And then number 19. Okay, so number 19, the value of a card depreciates. So when we're talking about the price of something either going up or the price of something going down, that's going to be exponential growth and decay. Depreciates, though, is going to be a decay. So this is A equals, you need to know, again, you need to know these formulas. 1 minus R raised to the power of T. So how many years? That's going to be T that we're looking for. So everything else we should be able to plug something in. So the value of a car is 3,000. So that's how much you're starting with. And the rate is 17.5%, which is 0.175 raised to the power of T. The question is, how many years will it take for the car to be worth half its original price? So if it started out at 30,000, half its original price is going to be 15,000. So we divide first. When we divide 15,000 by 30,000, this cancels, or 0.5, which is equal to 0.825 raised to the power of T. So I need logs. So this is the log of 0.5 equals T times the log of 0.825 divide by the log of 0.825. So it cancels here. Here in my calculator, I am rounding to the nearest hundredth of a year. I get that the time is equal to 3.60 years. Okay, and then the last question that's talking about exponential equations deals with number 20 with the mosquito population. So if you finish reading this question, this ends up saying increasing over here. So increasing, this is going to be an exponential growth. So I need this formula. Okay, my question is asking how many mosquitoes will be on the island. So I'm looking for A. Okay, so I should plug in for everything except A. So this is actually going to be kind of nice because now I don't need to use logs for this. So my initial amount is 1.6 million. I don't want to plug in a whole bunch of zeros, so I'm just going to plug in 1.6, and remember I have to put million at the end of whatever my answer is. So 1 plus my rate. My rate in this case is 2%, so this is 0.02. Raised to the time, we're talking about 6 years. So this I can plug right into my calculator. When I plug this in, I get A equals 1.8018598. All right, but again, we were talking before about million. So million, you have to move back over 6 decimal places. So we start here, and we're going to round off here. Okay, so this number in millions is really this. 1,801,859.8. But we are rounding to the nearest 10,000. So if we round to the nearest 10,000, so you have to remember your place value. 10,000 is right here. So 10,000. So when I move this over, this is going to be 1,800,000 mosquitoes. All right, 21 and 22. These are my lovely parabola questions. Find the equation of the curve equidistant from the point 8,4 and the line y equals -6. So 8, 4, that is your focus. So why don't we go ahead and just draw this quick, just so we know what we're looking at. So 8, 4 is going to be 8 and then 4 up here. And then my directrix is -6. So that's going to be right here. Okay, so if I go halfway in between, so this distance here is 4, This distance here is 6. So I move a distance of 10. So I have to be 5 in between. So I'm going to be at 8. My vertex is going to be 8, comma, negative 1. My p-value is the distance from my vertex to my focus. So this is my vertex here. I'm concave up because the focus has to be inside your parabola. My p-value is going to be positive, and then I'm going up. I just told you I'm going up 5 units. So I have to plug this into this equation. 4p y minus k. When I type this into this equation, or when I substitute everything in, my final answer is x minus 8 squared equals 20 times y plus 1. And that's it. That's all you're doing. So then for the next one, now my focus is -2, -5. So -2, -5. And then my directrix is y equals 3. And then this is my point. Okay, so I am, if you count, I am 8 units away from each other, right? So I have to be 4 in the middle. So 4 in the middle, I go up 1, 2, 3, I am right here. I am right here, and I'm going to open up this way. So I'm opening up downward because my focus is down here. So my vertex is the point -2, comma, -1, and my p-value is going to be negative because I'm concave down. It's going to be -4. Okay, again, this is my equation. X minus 8 squared equals 4p y minus k. So my final answer here is going to be x plus 2 squared equals -16 times y plus 1. And that is my final answer. Alright, last 2 questions on here they look like doozies, but they're really not too bad as long as you know your rules. So here, first let's clean up these radicals. So this is really a raised to the 5 over 3, and this is a raised to the 7 over 2. Remember, your root becomes your denominator, your power is your numerator. It's all being raised to -1/2, but I'll deal with that after. So when I am dividing these two, I need to subtract the exponent. So in my calculator, I can right away just do 5 over 3 minus 7 over 2. And when I do that, I get -11 over 6. I know it looks messy, but... So now, power to power, I have to multiply. So this is a to the positive 11 over 12. However, if I want to clean this up, I don't want fractional exponents. If I want it in radical form, this 12 comes out here. So this is the 12th root of a to the 11th power. And that is my final answer. Okay, for this one over here, for number 24, it's not in radical form, so you can right away just subtract those 2 exponents if you wanted. So this in here, you end up getting 1/3 minus 3 over 2 gives you -7 over 6, raised to the -5 over 2. So when you do power to power now, you get m raised to the 35th over 12. So this isn't very clean. So first I'm going to clean this up by putting it in exponent form. Okay, however, if I look now, it's still not in simplest form because I can simplify. 12 goes into 35. 12 goes into 35 2 times. And then you have a remainder, so you still have a 12th root. 12 times 2 is only 24, but I need to get up to 35, so I am missing m to the 11th, and this is my final answer. Alright, just a reminder, extra help is going to be on Wednesday after school from, well, until like 2:30ish, and then I have to go. But on Thursday, I can stay until about 3. Okay, so I hope to see you there. Happy studying.